In this video, I'm going to show you how to create a shader that can create all of those variations that you see here on the screen. This is the second part of my atom model tutorial where I wanted to show you how to create these circular wave patterns and then a bit of color adjustments. And then I just thought, let's see what else this shader can do. And yeah, I think it can do quite a lot, like lots of different interesting effects. Obviously, I'm using different textures here. This is one of my favorites. I think it's like Alien Fork Eggs suspended in ice at just the right temperature. So, So you're still going to learn how to create circular wave patterns with a sine wave, how to animate that. But on top of that, I'm also going to show you how to use polar coordinates, how to rotate UVs, how to animate polar coordinate UVs, and how to do some color and alpha adjustments based on the radius. And last but not least, I'm going to show you how to create a helper script to create these textures, to offset them, so it's a lot easier to play around with that. And of course, it also has these assigned materials to all the wings, so you can see like what might look good and interesting. And yeah, this tutorial is aimed at intermediate users. You should definitely have an understanding of shaders, of Unity in general, because there's a lot of stuff we have to get through. I think this tutorial is already going to take way too long. And so I'm just going to be moving really fast to see it more as like an overview like of how you can do that. So you should be quite familiar with creating shaders, but then I think it can be quite useful just to see some different techniques that you could try out for yourself. Of course, if you're new to shaders, feel free to follow, ask a question. That's totally fine. For the mesh, I'm using this circle with insanely high poly count. This is, of course, for demonstration purposes. The vast majority of shaders would work with a much lower poly count, but prefer to, when I create the VFX, to just go with something high and then reduce it to whatever's needed. And of course, the UV map is as straightforward as it gets. Just put the entire circle onto the square because it fits so nicely. And one thing to note here, this is a unit circle, so it has a radius of 1. If we zoom out in Blender, right, you can hopefully see this square here. This is a 1 unit in Blender. And of course, with my FBX export and import settings, that is then going to be 1 Unity unit, and that is relevant for the shader. And then of course in Unity, I just used that mesh and I simplified the shader, set all the values to 0 so we can go through this step by step. And the first thing I usually do is create something for the scale. So we just take the vertex position, multiply it with a property, a simple float called scale, and then we register the scaled vertices local. And then I'm also taking the length, so it just takes in vector 3, right? It gives you the magnitude of a vector. And if we divide that by the scale, then we always get the distance for every vertex from 0 to 1, right? So at the middle, it's always 0, and at the edge, it's always going to be 1, no matter what scale we are using. And this, of course, works because what I just showed you, we're using a mesh where the outermost vertices have a distance of 1 unit. For the shader, I'm using absolute vertex position, and so now I just take the scaled vertices and put them into the vertex position. And of course, in a moment, we're going to add the offset for the waves. But just to show you real quick, of course, now we can change the scale. And if the scale is at 1, this should be exactly 1 Unity unit as a radius, assuming the object is also scaled at 1. And so we can now control the scale. And while we're at it, I just want to show you real quick, I'm doing the same that I did in the first part of the tutorial. I'm using a C# script to make sure that every object has a tiny offset that is basically invisible to the user. But then I can grab that right here, the object position, that is the position of the object in the world. I take the x, multiply with 1000, get the smallest integer of that, and then subtract it. So now I get a fraction from 0 to 1, and I store all of these as random values. So I have a bunch of random seeds, and I can easily just create a lot of objects on the fly. I don't have to create new material instances for every object. Now, to map the sine wave following the circumference, what we need is the angle of every vertex to like one reference direction. So the first vertex here would be like 0, and then it goes all the way around to 1. And then, of course, we can use a sine wave in lots of different ways to create this wave that goes around the circumference. So all we really have to do is get a reference vector. We can really use anything, just any vector that we can compare all the vertices to this one. And we're only going to need the x and z, right? Because we don't really need the up. This is a flat circle. So we take the vertex position, x and z, turn this into a vector 2 where we disregard the y, then we normalize it, and then we use a reference vector. And this can be pretty much anything. If you don't use something that is like 0 and 1, then you also need to normalize it, right? Otherwise the formula is not going to work. And yeah, you take the two normalized vectors, calculate the dot product, and here you multiply the x with the y of the other one and the y with the x of the other one or the first one, subtract the results from one another, and then you take the dot product and you calculate the arctangent, and what you get is the angle in radians. And the really, really nice thing is this one goes from 0 to 360, or rather it goes from minus pi to pi, but it's gonna grab the whole 360 range of the angle. And you may have noticed when you've used some of the built-in Euler functions in Unity that it doesn't do that. It just goes from like 0 to 180, and it doesn't do negative ones, and it can lead to some really weird results. I even had a method once where I set it to the same exact angle, and every time I trigger the method, it would just flip it around. Like sometimes it makes it positive, sometimes it makes it negative. So you can, of course, use this method in C# too, right? And I highly recommend doing that. Don't deal with the built-in Euler stuff. And so radians means it's going to go from minus pi to pi. So we are going to register this one straight up as angles in the arctangent, but we can also just remap that. And so remap the result from minus pi to pi. And now we get this angle from 0 to 1. And here I'm going to set the alpha to 1, plug this one in, and now you can see we get this nice angle that goes from 0 to 1, right? We can compare all of this. The angle in radians is actually quite useful because sine waves go from minus pi to pi. And so we can actually just use that directly, and then we know this is going to go like one fold back and forth from minus 1 to 1. And so if you multiply this with an integer to get how many waves we want, let's just plug this straight into our sine wave node. And here for debugging, I plug this into a sine waves value node. And if we change this here, sine waves value, save it. And now you can see we get these like nice sine waves. And of course we have this wave counter here. It shows as a float, but it always gets rounded down. So this is 0 waves, it's all black. Now we have, this is exactly one sine wave, right? And of course it goes to minus 1 here. We haven't remapped it yet. And so we can increase that. And actually let's do the remapping real quick. Did I do the remapping? No, I didn't do the remapping because I want the waves to go down actually. So I keep it at a minus 1 here. I want the wave to go up and down from the original position. So I have the sine wave here, and now we can use that and use some strength. And I did two things here instead of just using the strength directly, so they all have the same. I said I want to have a wave strength in the center, and I want to have a wave strength at the outer edge. And this is the variable that we saved earlier that I said that it's always going to be 0 to 1 no matter the scale, right? And of course, so we can, if we just use a normal up here, we can do that. But of course, we can also use this power. So since this is always 0 to 1, it's pretty safe to use a power value. Then you can just get like sharper gradients. So we multiply that with the output of our sine wave, which goes from minus 1 to 1. So we have the strength here, and then we have this vertical offset for our waves. And let's actually just plug that in as a color first. Okay, so you can see now I could say I want to have it really strong at the edge, and it's starting to glow because it goes, the values says it's more than white, and can have this at the center. And what I said with the power, right? So power of 1 means it's just going to be a very linear program. Let me actually show it from 0 to 1. That should be a bit clearer. And so the wave strength change power 1 means it's just a linear progress, but if I increase the power, right, then we can get like a much sharper progress. And if I increase this one, and of course you can also use it the other way around. And let's actually use that for the actual offset. So let's just take the same output that we're seeing here as 0 and 1 or -1 to 1 and turn this into a vector 3. And for this one, I only wanted some offset on the vertical axis. Of course, you can get fancy with it and do all kinds of like weird transformations, like maybe increase the radius based on the like where it's white and where it's black, and then you get like these cool wobbly lines. But the shader is already complex enough. So let's just use Y vertical offset. We add this to our scaled vertices and we plug this into the vertex position. And now, actually that's exactly how it was. I was just looking at it from the top. But that's a bit too much. Let me actually add some of the original color here. That's the remap color texture. We're going to get to that in a moment. Yeah, so the wave strength is quite extreme here at the edge. Let me reduce that a bit, but you can see we can deform it at the edge. We can deform it at the center. I hope you can see that. Might actually make sense if let me add the alpha. Makes it a bit easier to see probably. And we're going to get to that in a moment, of course. Maybe I think this might help a bit to see the deformation here, right? So we have the wave strength at the edge or at the edge, or the center or both. And then of course we can say how drastically we want that to change, just linearly or smoothly. Now, if we want the waves to go around, like where they're up and where they're down, we can just offset what we plug into the sine wave here over time. So here I have waves rotations per second. I multiply it with 2, right? So again, sine wave goes from like, or rather 2 pi is like 1 full sine wave. For some reason I always say minus pi to pi, but it's not really relevant. Anyhow, 2 pi gives you 1 full sine wave. So if we multiply this, the output, like how many waves we have, multiply that and plug that into our time node. And then all we have to do is we're just going to add this to what we plug into the sine wave. And now we should have an animated wave if we find the slider waves, rotations per second. Yeah. So now our waves are moving. And one last useful thing here for the waves, I'm also using like a random offset per object. So this is if you have like multiple of these textures, you probably don't want to have the waves exactly in the same place because then it's just going to overlap. So I grab one of these random seeds that I created. Let's this behind it. Okay, so I multiply it with 10. So I can still have the option right in the editor. If I multiply with 0, then yes, all the objects are going to have the waves at the same position. Sometimes that's interesting for like symmetry. If you have the objects rotated, but then the waves are all in the same place, you can have some like these really trippy symmetry effects. But if you want it to look a bit more natural, then it might make sense to have some offset. So every object has the waves at a different position. While height and speed is still going to be the same. And we just add this here before we plug this into our sine waves. So now the offset is just different. Okay, so let's talk about the texture and the polar coordinates. So first of all, I'm going to reduce the wave strength here. So just to show this. As I showed you earlier in Blender, right, the texture is mapped pretty much as if I just taken the object and just like slammed it onto the UV map. So if I use a tile texture, this is what it's going to look like. But it would be really useful if we could do something like that. And for that, we can use the polar coordinates. And so all you have to do is use this polar coordinate node, right? 0.5, 0.5, most likely the center that you want to use. If you have the UV map that I just showed you, then this is definitely the center you want to use. And here we have this radial scale and length scale. We'll get to that in a moment. This is actually for scaling this. And as you can see, I can also offset that. I just plugged this into like a compare node. So use polar coordinates. I'm using this as a Boolean. 0 is false, 1 is true, or that anything bigger than 1 is true, right? And so if this is bigger, then I plug in the polar coordinates into my texture. And oh yeah, I also get the value. So I take RGB, add them all together, divide them by 3. because I want to remap the color, but we'll get to that in a moment. Alternatively, of course, just normal texture coordinates, right? This is straight up the UV map that I have. So for both scenarios, there are actually like two shared variables. The first one is the texture scale. That is quite straightforward. For the normal ones, right, if you want to scale a UV map, of course, this is 0 and 1, and of course we don't want to just start scaling from here to there, because then it just gets stretched. We want to move this point down here, and then we scale around this point, and so very straightforward. Subtract 0.5 and 0.5, a vector 2. Then we multiply it with the inverse of our scale. So if I say scale increases, right? Of course, I could just plug that in directly, but then it means increasing the scale property. The texture is going to get smaller, so I just use the inverse, multiplied, and then we need to add it back for what we moved it earlier. So this would just be the normal scale. So then we have the rotator, but get to that in a moment. Just show you for the polar coordinates, if you want to increase the scale, all you have to do is plug it into this one. And now let's see, for this one, I should use polar coordinates. We have scale somewhere here, texture scale, right? So we can increase it like that. And of course, if we have a circle, sometimes you get funky results when you plug the circle into polar coordinates, but probably don't want that. Here we have the scale too. Now both versions can also be rotated around the center. So here I have text circular speed, plug this into a time node, and then to make sure that every object has a different offset, starts at a different rotation. And here I didn't even expose it as a property because I know I want that for pretty much every scenario. So this goes from 0 to 1, so I just multiplied with 100 to make sure it's definitely at a different offset. Right, I add this to whatever the time gets me, and then I register this to circular speed, timed, and offset. Sometimes variables have to be long to be precise, but that's okay. For the polar coordinates, we can actually just add a vector 2. This is very similar to what you would do with like an offset, right? And we have to add this to the y component. So we're getting this u and v out, and so the y is the one that goes around. And we can use it here. And for the normal UVs, we can just use this rotator node, 0.5, 0.5. So what is the anchor of like the center point that we want to rotate around, right? And of course, we made sure that our UV map is still centered the way it was before. And so we can just rotate this around. If you don't have anything in here, it's going to use the time. But as soon as you plug in a float, it's no longer actually using the time. Then it's just like a fixed time. So if we want this animated, we need to make sure that it has the time property in here. And of course, we do that, right? Because we multiply our property with the time before we register that. That can be quite confusing sometimes, but yeah. And so now we can rotate our texture circular speed. Right here, we just rotate the UV map. Sometimes these AI generated textures are not quite centered. That can be a bit annoying because then it looks like they start wobbling. This one is, that is pretty cool. So it works for this one, and we plug this one in. Well, it also works for this one, but I mean, if you use polar coordinates, right, now we're rotating around this one, so let's make this a bit smaller. So yeah, that's pretty cool. Polar coordinates now has two kind of like extra things that we can do. One is we can have the polar length here. So I'm using an integer. So once again, it shows like a float. The editor is just not very good for materials, but it's 1. I can also double that. And now you can see it's going to get used twice, right? Because we can tile it on that axis too. Obviously, we can't really do that with a circle. And we can also move it inward, because basically what we're doing now, when you look at this texture here, we're offsetting it on the vertical axis, right? The y. This is why if you were to just use normal texture and offset on the y, they're all moving up. And so they're all just moving like around. But we can also offset them on the x, on the x-axis. And that is the radial speed. So if I set this to 0, and then we can have the radial speed, right? If it's negative, then it's like they're all moving out. If it's positive, they're all moving inwards. And of course, we can then combine that. And so they're kind of like, this might be a bit too fast sometimes. You don't see this anymore, but while they're getting sucked in like this circular motion, which is quite cool. So this only works for the polar coordinates, right? So polar length is super simple. Just plug it in, or the pre-made node here has that already. That's pretty cool. And yeah, as I just said, like for the right, to move it upwards, which means this is going to be around, we use the y, and for the other one we just use the x, and we do exactly what we did with the circular speed. Just here, plug this into a time node, make sure that every object has a different object offset, add it to the time. Then we append these two vectors and the x and y to a vector and add this to the polar coordinate. And of course, this is going to be the one that we plug into the texture. Okay, so now that we know how exactly we want to sample our texture, let's do something with the value. So I'm here I'm using RGB and adding them together, dividing them by 3, which is of course very inefficient if you just want the value. You would maybe only use the wedge and store all that information in there. And of course you could also use the color from that. But for the sake of this tutorial, let's just like roughly grab the value of the texture from a 0 to 1 range, right? We store this in a variable here. And what I showed you in the last video, I'm using this for a 3 color lerp. So at 0, I want this color, at the mid-range this one, and 3, and well, at the highest range this color, and then I have the slider so I can determine where these ranges start and also how fast that blending happens. So now I could just plug in this texture, but let's actually do a little bit of multiplication, and we're going to do that based on the radius. So that variable that we saw at the beginning, that is always 0 at the center and 1 at the outermost edge of our circle. And I have two factors now, and it's pretty similar to what I did with the waves, just a tiny bit more flexibility. So I want to have a multiplying start factor. So at the center, I want to multiply the texture value with one value. And at the edge, I want to multiply it with another value. So I lerp between those. And to lerp between those, I have this start and end position. So instead of just saying I want to lerp from 0 to 1, I might be able to say I want to lerp from like 0.2 to maybe 0.8. So after 0.8 of the radius, I want to completely have the end factor. And if I say I want to start at 0.2, that means anything below, I'm getting this like multi-start factor completely. And only in between those two values, this is where I want to do the lerp. And on top of that, to not just like lerp linearly, I have this value multi-power. Once again, we're getting a value 0 to 1 out of that, or rather, since we're using a saturate node, which means we are clamping this to 0 and 1, we can safely use like this power node. And yeah, just either like if I set it to below 0, then it's going to like almost like a less than a linear gradient, where it's going to be slower. And if I crank this up, it's going to be super sharp. Actually, let me show you that. And what I do a lot in Shader Graph is just register that. And I find the node, my variable, and plug this as color alpha 0 and make this down. And let's look at it from the top. So now if I set the multi-start factor to 0, well, we're going to get 0 in the middle, and multi-end factor to 1, it's 1 on the edge. And what I said before, I maybe just actually want to start a little bit later, so I can say let's start here, and then we lerp. And how strongly we lerp, that is the power. 1 means it's going to have no effect, but something to the power of 1 is whatever that something was. But if we increase it, it's going to get super sharp. And of course, if we decrease it, it's going to be the opposite. And keep in mind, or rather note, that I set the minimum here to 0.01, because something to the power of 0 is just going to explode. So if you use like a power, it's always good to say like this tiny minimum. Then we can have this lerp. And of course, we can also say I want to reach 1, but I actually want to read this sooner. So and position, right? This is where I could say, well, I want to add 0.6. So only really looping here. And then of course I can flip these values and, well, that's not flipping. 0, 1, start factor could be 1, and so on. I'm using values here much bigger than 1 because the value that comes from the texture might be like 0.1, right? And so if I want to like really crank this up, I might want to multiply it even with, well, here I only had 5. I think that was enough for my use cases. But then I can say, okay, from 0.1, it just gets cranked up quite a bit. And then I'm doing exactly the same for the alpha. There's really nothing to it other than the values have different names. And I'm storing this as the alpha mask, right? Again, this is a multiplier. So if I set the start factor to 0, then it's going to, like the alpha is going to be 0, which can be quite helpful because then you can say like, I don't want to show anything in the center, or what I use quite a bit here, I said, always want to end with 0 alpha, right? And then with the end position, I can say, you know what, I just only at the very edge of the circle, I want to have 0 alpha. And I take this alpha mask. And so this is the color that we get out of the remap. I split this into RGB. And I can also plug this into the color, but the alpha is separate. So I take the alpha that I get out of the remap color. I take this alpha mask. And what I also did, I made sure that if the texture is below 0.01, I actually want this to be 0, and just to get rid of like all the blackness in the textures, so I have a little bit more control over the colors. Anyhow, plug this into the alpha, and yeah, that is pretty much the entire shader. And so let's say value multi start position, right? So at 0, we don't want to boost the value, but we could also say, yeah, let's boost the value. And boosting the value then means we're getting closer to this color. So if I make this like orange, right, you can see because we boosted the value up in the beginning, and if the value is high, we're getting close to this orange color. Alpha multi start position. So I have it at 1, 1, right, so it's not going to have any effect. But I could also say alpha multi end factor. So in the end, I want this to disappear, right, to have the alpha fade out. And I could say, but maybe not at the edge. No, actually a little bit sooner, right there, or only here. And if I want this to be strong, what I showed you earlier, right? So I only really want the outer edge, then I can use this alpha multi. And so we're still getting like this nice soft edge, but we're still having quite a bit of control to select. Don't start too soon with that. And then of course, wave strength, center, edge. Okay, last but not least, let me show you the Zapper script that I have here. So I can create a bunch of variations quite quickly, and I can say how much each should be rotated. And so if here I want to have 2 or 3, maybe I want to have more rotations and so on. One thing to note, this one has a mesh renderer, but it doesn't have a mesh filter. And the only reason it has a mesh renderer is so that the editor shows me the material that is assigned to that mesh renderer. So just the helper script, because all the wings have this material that I'm going to assign here. So it just shows up here in the editor, just really more like a tool. So, I mean, you can also disable the mesh renderer. So the script itself is quite straightforward. I have a renderer that I use as a wing prefab, right? So one wing that is assigned. I have a list of the renderers that are all the wings that exist, and I have a material that I want to assign. And the preview renderer, that is what I just showed you, the mesh renderer that is really attached to no mesh at all. Then I have an integer for how many wings I want to be showing, and a range slider, rotation X and rotation Z, so that is the step between all the rotations. Then I have one helper script that says assign the material that I have here, the wing material, assign that to all the wings. And of course, it's important that you set it to shared material, not material, because then it's going to create new instances in the editor, but it gives you a warning and says, please don't do that. So just assign this as the shared material, so it's still the one instance we have. Just wings count one second real quick. On validate, using this onValidate method, which gets triggered whenever a value changes in the editor. I say adjust wings to count and adjust noise to wings position. So every time I move this slider, these two methods get called, right? This one's actually pretty straightforward. A tiny noise wing position, just this tiny offset that I can use in the shader as random seeds, and 0.01 is probably not visible, that they actually at a different position, but yeah, get so many random seeds out of that. And then adjust wings to count, so we just take the X and the Z. This is a new float here at 0. And then we just run a loop for how many wings we want. If we don't have enough wings in our list, we're just going to instantiate a new wing. And then, of course, make sure it's enabled. And here I just flip between like the rotations, right? So if the first wing is never rotated, actually in this case, of course, you can change whatever you need. But then I just say if the rotation is smaller than 0, then increase the rotation. If the rotation is positive, then flip the rotation. So it always goes back and forth, right? If I say X rotation 20, then the first wing is going to be 0. Second wing says, okay, it's not smaller, or it is smaller, equal to 0. They make it 20, and then the second wing is going to say, it's positive, it's 20. Let me make it minus 20. And then the third wing is going to say, it's minus 20. Therefore, take the absolute at 20. So we're at 40. And the fourth wing says then, we're positive. So let me just flip it. So minus 40. So it always goes back and forth. And then I adjust the rotation for every wing. And that is really all there is to it. Oh, one last thing, of course. To make sure if we might have more wings in our list than we actually want, then it's just gonna get disabled, right? So they stay in the list. And if I go in here, while we have all these wings, I'm just gonna crank it up to see that they get created. No, it's on. Oh, already had 20 wings. Okay, well, probably don't need that many, but you can see the mesh one where it gets disabled, right? So this one. And thanks to the onValidate method, I can also just change the X and Z, and then every time that method is going to get called, that goes through all the wings and assigns that. All right, thank you very much for watching. I hope you've learned something, as always. And of course, feel free to leave a comment, questions, feedback, criticism. If you didn't understand anything, that's totally fine. Just ask it. Really doesn't hurt. I'll check the comments, and I'm glad to help out. It also helps me to understand where I should maybe do a better job at explaining some things. And yeah, of course, feel free to grab all of that stuff from my GitHub. If you use this for something, please let me know, because I would really like to see how this gets used in something. And of course, as always, liking and subscribing helps me out quite a bit. And yeah, let me know what you want to see next. I think I'm actually gonna try to do some like animations here, right? Because I mean, right now we only stayed in edit mode, but we can do so much if we actually animate some of these values. Like this could be a charge up, and then we could use some kind of explosion and like lots and lots of cool stuff. But first, I need to finish up a mixed reality drone. So the next videos are going to be about some like sci-fi thrusters, which are always a favorite of mine, and then how to actually fly a drone in mixed reality, specifically the Quest 3, which is a lot of fun. So hopefully see you in the next video, and goodbye.